Hi guys, today we're going to look at some inverse trig functions. I know you love trig and now we're going to do inverse trig functions. So remember, it's important that you know the domain and range for the inverse trig functions, okay? Remember, sine and cosine have a range of -1 to 1, which is why the domain of cosine inverse and sine inverse is from -1 to 1. In order for those to be functions, we discussed in pre-calc last year the range for each of these inverse functions so that they are indeed functions. Now, not only do you have the notes there for you, I gave you the graphs of each inverse function along with the domain and range, because I know some of us are much more visual and it's easier to see when we're looking at a picture. But some of us like to just have things written down, so I gave it to you both ways. Be familiar, okay? Because now what we want to do is there is a theorem that says if a function is differentiable on an interval and dy dx is never 0, so the derivative is never 0 on that interval, then f inverse is differentiable on the interval, okay? Note, the derivative not equal 0 means that the function is strictly increasing or strictly decreasing. The derivative exists, but it's never 0, so it's never staying level, never has that horizontal part. That means you're going to have a strictly increasing or a strictly decreasing function. Okay? Now, those will have inverses that have derivatives. Now, we're going to look at the function sine inverse of x. You ready for this? So let's say we let y be sine inverse of x, okay? So if y is sine inverse of x, that means that the sine of y is x, correct? Because we know how to find the derivative of sine, so it's easier if we do this. So now we're going to take the derivative with respect to x, okay? So we take the derivative with respect to x of sine y equals the derivative with respect to x of x. Now be careful here. The derivative of sine is cosine, keep the angle y, times the derivative of the angle y is dy dx, equals the derivative of x is 1. That means that dy dx is 1 over the cosine of y. Now the problem is this is in terms of y instead of x. So I want you to think, and I'm going to come back to a little right triangle, and I'm just going to use the first quadrant for simplicity's sake. Okay, here's the angle y, right? Because we're taking the sine of y. Now sine is opposite over hypotenuse, so it must be x over 1 in order to get us just x for the sine of y. Now what's this missing side here? Well, let's see. We've got, let's call this a squared plus x squared equals 1 squared. So a squared equals 1 minus x squared. So a is plus or minus, depending on which quadrant we're in, minus x squared. Okay? So that's this side, plus or minus the square root of 1 minus x squared. Now, if we want the cosine of y, so dy dx equals 1 over. Cosine is adjacent, which is this piece, over 1, so it's just that piece. We also know that since, remember those domain and range things? Since y equals the sine inverse of x, we have negative pi over 2 is less than equal to y, less than equal to pi over 2. That means that cosine, because think about this, from negative pi over 2, that's here, to positive pi over 2 here, we're in quadrants 1 and quadrants 2. And all students take calculus. Cosine is positive. So that means that our dy dx equals 1 over positive square root of 1 minus x squared. There we go. Now we found it. Now once you have one, I'm not going to go through proving all of them. Here are the inverse derivatives for all 6 inverse trig functions. yes, you should know them. I know that's not fun, but yes, you should know them. Sine inverse, definitely. Tan inverse, definitely. Those are the ones that show up most often on the AP exam. All right, I will be honest, those are the ones I've seen most often, but technically they can all show up. So you need to be familiar with all of them, okay? I know it's not often I tell you to memorize something, but here we are. Now you'll notice when you turn the page, aha, this looks almost the same, except my x is turned to u's, and then there's this little extra du dx on all of these rules. This du dx on all of them is simply a reminder to use the chain rule. Okay? It means when you have an angle, don't forget to use the chain rule. Okay? And we'll go through one that looks just like that. See, here we have the derivative with respect to x of arctangent of x cubed. Okay, so our angle is x cubed. That's our u. So if we follow for arctangent, that's this one. Now remember, arctangent is the same as tan inverse of x cubed. They're the same, okay? So now we're going to do 1 over 1 plus the angle, which was x cubed squared, just following this rule, times the derivative, we're using the chain rule now, the derivative with respect to x of the angle. Well, the derivative of the angle is 3x squared. So now we're just going to simplify that. That 3x squared is in the numerator. 1 plus x cubed squared is x to the 6th. And you've done your first inverse trig derivative. Yay! Let's try another one. Now look at this. This should look familiar. The limit as x approaches radical 3 of g of x minus g of radical 3 over x minus 3. That is simply g prime of radical 3, right? Okay. Now if g of x is sine inverse of x over 2. Now let's see, this is sine inverse, so remember, I'm going to copy it from the previous page. The derivative with respect to x of sine inverse of u is 1 over the square root of 1 minus u squared times du dx. And our u this time is x over 2. Okay, so when we take this derivative for g prime of x, that's going to be 1 over the square root of 1 minus, now u is our angle, x over 2, and we have to square it, times the derivative of our angle. The derivative of x over 2, remember that's just 1/2 x, is 1/2, which means if we want the derivative at radical 3, because remember that's what we're really looking for, this is 1 over, I can put this 2, right? This 2 can go up front. 1 over 2 times the square root of 1 minus radical 3 over 2 squared, which is 1 over 2 times the square root of 1 minus, now radical 3 squared is 3, 2 squared is 4. What's 1 minus 3/4? That's 1/4. And the square root of 1/4 is 1/2, and 2 times 1/2 is 1, so that means that g prime at radical 3 is simply 1. So that whole limit that we started with is 1. One last problem. This time we're going to find the derivative with respect to t, so instead of x it's t, of cotan inverse of cosine t. So our angle for the inverse function is cosine of another angle, okay? So the first thing I'm going to do is I'm going to write down the rule so that I have the model in front of me of cotan inverse of u. So the derivative for cotan inverse of u is -1 over 1 plus u squared. I like the tan inverse and the cotan inverse because there's no radicals. But notice how all the co-functions had negative ones and all the ones that didn't have the prefix co were all positive, okay? So if you see what I'm saying, when you look here, all the ones that start with co, all have negatives. The ones that don't have co are positive. Times, whoops, we forgot to write, and this time it's going to be du dt because we don't have a dx. All right, so here we go. We're going to follow this pattern. -1 over 1 plus, now our u is that cosine t, and we're going to square it, okay? Times du dt. What's the derivative of cosine t? That's negative sine t. So if we multiply that, a -1 times a negative sign is just sine t over 1 plus cosine squared t, and that's it. The hardest part of this is knowing the rules for the inverse trig derivatives. Okay, so unfortunately, yes, you do have to study them. Okay, but the inverse for sine is very similar to the inverse for cosine. The derivative of tan inverse is very similar to the derivative of cotan inverse. Same thing with the derivative of secant inverse and the derivative of cosecant inverse. They're just negations. The co ones are just the negations. Okay, very much like our original trig functions. Okay, guys, we're going to stop here. I hope you have a wonderful day. See you soon.